So, right, hi everyone, and we again welcome you back to this next lecture, guys. And basically, it's going to be all about the practice session, guys. So, here we will be mainly seeing some of the questions based on whatever we explored in the last lecture, guys. So, guys, if you haven't gone through my last lecture, I just recommend all of you guys to go through it so that you can understand the concepts and apply them as well in this video, guys. Right. So let us quickly head on to what we explored in last lecture, guys. So first we discussed all about what is motion, like it is the movement with respect to surroundings. We discussed all about the parameters which are required to describe the motion of an object. And thereby we saw the difference between the distance, displacement, speed, velocity. We explored all about acceleration. So guys, basically we focused on these parameters and we gave a proper description for these parameters, right? We also explored what is scalar and what is vectors, what are the examples of some scalars and vectors, what is the difference between them. Like we saw that scalars were having only magnitude, vectors were having magnitude with direction as well, right? So I would just recommend you all guys, those who haven't gone through the lecture, go through them and then return back to the session to practice the questions. You will have a clear understanding, guys. All right, so let's quickly move on to the very first question here. It's written, an object moves through a distance. Can it have zero displacement? If yes, give an example. So guys, just think about it. The question is all about object moves through a distance. Will it have zero displacement in any kind of motion? Yes, there is possibility, guys. If the object moves around a circular path, let us say object starts from point A and moves in anti-clockwise direction and returns back to A. So from A, it has moved and returned back to A. So definitely the object has covered some path. And we know the total path length covered is distance. So here we observe that distance is not zero, but displacement here is definitely zero, guys, because the initial and final points coincide. We will make a note here. When initial and final points coincide, the displacement is zero, right? All right. So moving ahead to the next question, guys, and here we have the next question. A boy moves along the side of a square field of side 10 meters in 5 seconds. What will be the magnitude of displacement of the boy at the end of 2 minutes? So guys, one very special trick I'll tell you to explore and just do any questions based on physics. So first thing is break every statement in the question line by line. So break it and keep noting down the information. Later on, you will be able to club up all the information and relate the quantities which is given in the question, and then you can find out and move ahead with finding solutions. So here, as we see, a boy moves along a straight line, and that is the part of a square field. And square field has side 10 meters. So every side is 10 meters because all the sides of squares are equal, right? It's written, boy is moving along the side of a square in 5 seconds. So here to here the boy takes 5 seconds, which is mentioned in the question. What will be the magnitude of the displacement of the boy at the end of 2 minutes? So guys, here the boy covers one side of the square in 5 minutes. We are required to find out the distance and displacement at the end of 120 seconds. So guys, if we divide, we can observe in 5 minutes boy comes to position 2, 10 seconds boy comes to position 3, 15 seconds position 4, 20 seconds boy returns back to its original position, right? So if we observe that in 40 seconds boy completes the circumference of this square. So in 1 second boy will complete 1 by 40 part of the square, and in 120 second it will cover 120 by 40. So that is 3 times. It will trace the sides of the square 3 times. So what will be the displacement, guys? It will be very simple. That is 120 meters. That's distance. That is distance. And if we talk about displacement, it's very simple, guys. Displacement is zero meter because the object is starting at this position and anyway after covering the sides of the squares 3 times it is returning back to this same point. So again initial and final points they coincide and hence we get the total displacement coming out to be 0 meters. All right, I think it's clear guys, and if it's not clear you can still comment up your doubts guys. We will definitely address it in the next lecture. So now let us move ahead to the next question, guys. So here we see that an object travels 20 meters in 5 seconds. So what is the distance traveled, guys? 20 meters. Time taken is 5 seconds. And then another 16 meter. What is the total distance covered, guys? 36 meters, right? At how much time it takes? 4 seconds. So total time we get is 9 seconds. So what is the average speed? That is the question. So guys, we know the formula for the speed, that is distance by time. It is not only distance by time, we will remember guys, it is total distance by total time taken. So total distance, it is 36 meters. Total time taken, that is 9 seconds. So overall, the speed comes out to be 4 meter per second. Again, the very simple question, guys. Okay, so let's move ahead to the next question. So here, guys, all of you are recommended to just pause this video and you can try it out. And in case you face any difficulty, then you can resume your video so that you will have clear understanding. Okay, so here it's written that Ram swims in a 100-meter long pool. Let us say this is the pool and that is 100-meter long. So Ram is swimming. He covers 180 meter in 1 minute. That means he goes 100 meter here and definitely he has to come back to cover 80 meters in this direction. So it's written, find the average speed and average velocity, right, of Ram. You have to find average speed and average velocity. So it's written that the time taken to cover 180 meter, it's 1 minute. So let's make it in seconds. It's 60 seconds. So guys, what we have as the time? 60 seconds. What is the total distance covered? Very simple. It's the total path length covered. What is displacement, guys? It is 20 meters. Because guys, again, if you observe, this is the initial position, but this is the final position. Because Ram has covered 80 meters along the same straight path in the back direction. So what is the displacement here? 20 meters. So now guys, we can easily put them in the formula and we can find out the average speed, which will be distance by time. And what is distance, guys? 180 meters. So 180 meters over, what is the time? That's 60 seconds. So speed comes out to be 3 meters per second. But guys, when we are required to find out the velocity, which we call it as average velocity, that is the displacement over time. So what is displacement here, guys? We found it is 20 meters. And what is time? It's still 60 seconds, right? Because total time taken, it has to be same whether it be for distance or be it for displacement. And it comes out to be 0.33 meter per second, right? So this is the difference between this distance, displacement, speed, velocity. Again, I'm recommending you all guys go through the previous lecture. You will have a very clear understanding about all these parameters which we are using in this session, guys. Okay, so let us move ahead with this simple question. So starting from a point, Rahul paddles his bicycle. So let us say this is the point. Rahul paddles his bicycle to attain a velocity of 6 meter per second in 30 seconds. So what is the velocity here? 6 meter per second. What is the time taken to attain this velocity? 30 seconds. Then he applies brake such that the velocity of the bicycle comes down to 4 meter per second. So from this velocity, he is applying the brake and the velocity is coming down to 4 meter per second. So guys, now you can clearly understand here. This is the point where this boy has applied the brake. That means this is the initial point, and this is the final point which represents the final velocity. And the time taken is 5 seconds to slow down to 4 meter per second. So you have to find out the acceleration in both the cases. So guys, here first case is when the bicycle is starting from a point. So if any object is starting, make sure you put the velocity as 0 meter per second, and that is the initial velocity. So here we have u as 0 meter per second. So guys, here there are two parts. One is when the velocity increases from 0 to 6 meter per second. So in this case, what is the acceleration? Final velocity minus initial velocity by time. So final velocity, what is it? The velocity at the final point of time, that is 6. Initial velocity is 0. What is the time here? 30. So we get 0.2 meter per second square. That is the acceleration in the first case. Similarly, if we look over here, this is the second case, guys, when the boy applies the brake. While he applies the brake, this is the initial point. And what is initial velocity, guys? 6 meter per second. What is final velocity? 4 meter per second. That means the velocity at the final point. And what is the time taken to reduce the speed? That is 5 seconds. It's mentioned, guys. So acceleration in this case will be again given by v minus u by t, and that will be 4 minus 6 by 5, and that will be minus 2 by 5, and that will be minus 0.4 meter per second square. So guys, here you can notice that in the first part, we got acceleration as zero point 0.2, and in the second case, we got minus 0.4. So guys, note it here that we have two kinds of acceleration. One is positive acceleration and the other is negative acceleration. Positive acceleration, it simply means that the object is speeding up. That means its velocity is increasing. Negative acceleration means that the object will be slowing down. Okay? Yes. All right. So I think this question is clear to you all, guys. So just make sure what we did here, just focus on the question, guys, and keep breaking the question statement wise. Line by line, keep on breaking and keep on writing the condition. And then later on, observe the question and just get the result. Okay. So moving ahead to the next part, guys. So guys, these are all the concepts which we had discussed in the previous session. Again, I'm recommending you all guys to just go through them if you haven't checked out my previous video. So guys, in the next lecture, stay tuned. We are going to explore all about the graphs involved in the motion, the equations of motion, which basically relates all the parameters, right? So whatever parameter we have learned, speed, displacement, distance, velocity, acceleration, equations of motion is going to relate all these parameters. And finally, we will be having discussion on the circular motion as well as momentum, which we had left, right? So guys, see you in the next lecture. And in case if you guys have any questions or any query related to what we learned or whatever videos you want me to make on different concepts, just mail on rashmi030295@gmail.com. So all right guys, keep studying. All the very best. Bye bye. See you in the next lecture.